Hello everyone. In this lecture, I am going to discuss positive and negative logic, and then after I will also discuss canonical forms. So let's first talk about the positive and negative logic. In digital electronics, in terms of binary variables, there are two things. We may have high voltage, just a moment. So high voltage maybe +5 or low voltage maybe -5. So we represent, let's say I'm saying high voltage is +5 volt and low voltage will represent either 0 or -5, right? Now we map these voltage levels. So in positive logic, the high voltage will be mapped as 1 and the low voltage will be mapped as 0. This is positive logic. On contrary, in the negative logic, the high voltage let's say +5 will be mapped with 0 and the low voltage let's say -5 will be mapped as 1. So this is we consider as negative logic. Now let's talk about the canonical form. So what is the canonical form? In Boolean algebra, we have Boolean functions, right? And Boolean functions we define by using n number of Boolean variables. So let's say if I ask how many, so I'm writing a question here. How many Boolean functions can be defined using, let's say, n Boolean variable, I'm saying, okay? Question mark. So if this is the question, let's try to understand how we define the Boolean functions based on the given Boolean variable. So let's say I'm considering there are, here I'm saying Boolean variable. So let's say I'm considering Boolean variables are given as 2. Now if there are 2 Boolean variables, there will be possibly 4 combinations which we may have in case we draw the truth table, right? So in case we draw the truth table, we will have possibly these combinations. So let's say 2 Boolean variable we can take like A and B. Okay. So we may have the combination of 0 0 0 1 1 0 and let's say 1 1, right? So these four combinations, and based on that, let's say we are defining a Boolean function f. Now the question is asking, if there are two Boolean variables, how many different Boolean functions can be defined? Now because this is a Boolean function, it will also have values in 0 and 1 for all these combinations, right? So at any place there are two possibilities, right? At this place it can be 0 or 1, at this place it can be 0 or 1, at this place it can be 0 or 1, or at this place it can be 0 or 1. So the total number of total possibilities, or you can say total Boolean functions, which can be defined by using two Boolean variables, it is 2 cross 2 cross 2 cross 2. That means 2 to the power 4, right? So because there are two possibilities, 2 2 2, 2 multiplied by 2 multiplied by 2. So overall, how many possible Boolean function can be defined with the help of two Boolean variable? It is 2 to the power 4, that is 16. Now in case we have three Boolean variables, in that case there will be 8 combinations of these Boolean variables, and every combination can be mapped with two different values, either 0 or 1. So 2 cross 2 cross 2, 8 times, it will be 2 to the power 8 in that case, right? So in short, if there are n number of Boolean variables, so in case of two Boolean variables, I'm saying this can be represented as 2 to the power 2, right? If there are three Boolean variables, so let's say the value of n number of Boolean variables are 3, then the number of Boolean functions will be represented as, so I'm saying nf, number of Boolean functions can be represented as 2 to the power 3. If there are three Boolean variables, we write like, if there are n Boolean variables, then the number of functions, you understand that, you can remember this, number of Boolean functions you can write 2 to the power n, right? So let me highlight this. This you can remember as a fact. If there are n Boolean functions or n Boolean variables are given, the number of Boolean functions which can be defined by out of n Boolean variables, it is 2 to the power n, right? Now that is okay. You define a number of Boolean variables. Let me wipe it out. Now let's take one example here. So I'm taking one example. The values I'm taking, let's say this is 0, this is 1, this is 1, and let's say this is 0. Okay, this is one possible Boolean function which I am defining. So because there are two Boolean variables, the function f, we can define total number of values which we have, or the term in which 0, this is 0th term, this is 1th term, this is 2nd term, and this is 3rd term. Now whatever the terms are high, we can say the function is defined in that particular manner, right? So if I define this is term 0, so in this function 0 doesn't exist, so I will write here 1 is there, 2 is there, 3 is not there. Now there are two ways to represent this thing. Let's say as I'm saying canonical, we are discussing canonical and standard form. So what is canonical form actually? A function, if I'm representing in the Boolean form and I'm writing a function, let's say you consider I'm taking a function f over variable a and b, defining this function, and this function I'm writing like a, b, or let's say I'm writing a bar. Now, whether this is in canonical form, what is the restriction is there? Every term must be having all the Boolean variables over which the function is defined. So if function is defined over two Boolean variables a and b, in every term a and b must be present either in the positive way or complemented manner, right? So this is okay, but here it is not okay. So this is not the in the canonical form, right? As of now, this is not in the canonical form. So let's say if you want to convert into the canonical form, how we can do it? So a b is fine because there are only two Boolean variables, but this a bar is not fine. So along with a bar, we can write here b or b bar, because b or b bar represents 1. So a bar dot 1 we can write, because a bar dot 1 will give us a bar only, right? So this thing we can write ab or a bar b or a bar b bar. Now it is in canonical form because every term is having all the variables over which function f is defined. So I hope you understand what is the meaning of canonical, right? But canonical forms are two. There are two forms uh, in which we can have these two standard forms. So let's discuss. Let's say we are having standard forms that we are discussing. Now in this, the very first thing we consider as sum of product in short SOP, and another we have product of sum, POS. Sum of product we consider as min term, and in this we use max term. So what is min term and max term? Let's try to understand that. Let's say I'm defining a function over three variables. So let's say I'm defining f over x, y, and z. So when I want to define a Boolean function f over three Boolean variables x, y, and z, let's draw the truth table for that. So let's say I'm writing the truth table here, and in this truth table there'll be 8 combinations, right? Writing something like this, it like this, okay, right? Now fill the values. So this is x, this is y, and this is z, and here you're defining f function. So it will be 0, the 4 times 0, and 4 times 1. Now we will have 2 times 0, 2 times 1, 2 times 0, 2 times 1. We have 0, 1, 0, 1, 0, 1, 0, 1, right? Now there are many possibilities. In here f may have this very first place as 0, or it may have this very first place as 1. So let's consider this is 0, this is let's say 1, this is let's say 1, this is let's say 0, and the remaining terms are let's say 1. Okay, so if this is one possible function I consider. Now generally what we represent is in min term or sum of product term, we represent 0 as bar. So if I want to represent this thing 0, that means it is x bar. Okay, if it is 1, that we will represent 1 as x only, right? Here 0 represent y bar or y complement, and this 1 represents y only. Similarly, this is z and 0 represents z bar. Okay, so this term, if I'm saying whatever the terms are high, so this term is high, this 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 is high. So that means this function f will have these 6 min terms. So we can write it in the product of sum, or sum of product, not product of sum. We can write it in the form of so min term we write something like, there is summation of min term represent like m, and what are the min term? This is 0th min term, so we write it like m0, this thing. This is min term 1, this is min term 2, min term 3, min term 4, min term 5, this row represents min term 6, and this is representing min term 7. Okay, so that means min term 1 is high, so we can write this 1 is high, 2 is high, 3 is low, so 4, 5, 6, and so this is the function. Now how we represent in sum of product form? This 1 will be represented here as x bar, y bar, z. So we write x bar, y bar, z. Or second term 2 will be represented as x bar, y, z bar, x bar, y, z bar. 4 will be represented like x, y bar, z bar. 4 will be represented x, this is x, this is y bar, this is z bar. Then 5 will be represented like x, y bar, z, x, y bar, z. 6 will be represented like x, y, z bar, and 7 will be represented x, y, z, right? So we consider this representation as sum of product. Why we called it as, here we are considering dot operator, although dot is not exactly product because it is AND operator, but it look like mathematical product. So this expression look like product, and OR operations, those we are having here, these OR operations, it is looking like sum or plus. So we called it as sum of, and for these dots, these terms, we are saying product. So this term we consider as sum of product, SOP form. Although there is no sum and no product, sum, these OR operator looking like sum and dot operator looking like product. So this term we consider as sum of product, right? Now there's another standard form which we consider product of sum, right? So there's another term we have like product of sum. This is also one of the standard canonical form. In product of sum, we are interested in zeros. We look for the zeros and we consider 0 as high, right? So in a function, wherever 1 is not there, there must be 0 because it is a Boolean function. So either it can have value 1 or 0, right? Now, so in product of sum, we start looking at those terms, those are having 0, right? And we write in the form of product of sum. So product means in between we are having here dots. Instead of these dots, we will be having OR plus, right? So the 0 in product of sum or POS form we represent like this. So function x comma y z, it will be represented like max term. We consider this product of sum as max term. So there are how many max term? This is 0th max term, then this is third max term. So whatever the term were missing here, those terms will be considered in the max term, and the representation is like this. If we represent this thing in terms of product of sum, in that case 0 will be represented like, so here we use the negative logic. I told you positive logic and negative logic. So in positive logic, high represented as 1, low represented as 0. In negative logic, 0 will be represented as like high and 1 will be represented as low. So here 0 we will treat 0 as x, right? So if we want to represent this 0, we represent x or y or z, and operation 3 will be represented. So 3 is x, y bar, z bar. So x or y bar or z bar. So this is the way we can represent this same function in the form of product of sum, and here the way in which we represent the same function in the form of sum of product. We will solve multiple problems on these. We will also convert, these two forms are interconvertible also. Okay, so I'm ending this lecture. See you in the next lecture. Thank you.